Welcome to the video lecture by Dr. Biju Vastavan for the course Math for Management. Uh, this is an explanatory video of the PowerPoints available on the Blackboard for week 10. Here we solve some problems from the topic 6.4 System of Linear Equations by Gauss-Jordan method. Before starting with a particular example of system of linear equations, we need to know three important things. First one is elementary row operations, second one is reduced matrices, third one is how to reduce the matrices. What is the procedure to reduce the matrices by using elementary row operations, and then we will go to solve system of equations by a reduction method, in other words Gauss-Jordan method. Elementary row operation, the first point is interchanging two rows of a matrix. So if we are given a matrix A with a 1 2 3 4 1 2 3 2 1 0, you can interchanging any two rows is called the first elementary row operation. You can interchange this one. So any two rows you can interchange. So I'm writing this one as R1 and R2 been interchanged. R1 stands for row 1, R2 stands for row 2. R1 is replaced by R2, 4 1 3, whereas R2 will be 1 2 3. So 2 1 0 remains there, row remains. So you can interchange any two rows any number of times. So that is the first operation in first elementary row operation. Second is multiplying a row of a matrix by a non-zero number. Take the from this resultant matrix B, take a row 2 and multiply it by 3. So what do you get? So first row has no change, it is 4 1 3. Second row will be multiplied by 3, it will be 3 6 and 9. Third row has no change, you can call it a new matrix to see. This is what by second operation, multiplying a row of a matrix by a non-zero number. Third one, adding a multiple of one row of a matrix to a different row of that matrix. So we can take from C, we can take one, this is row 1, this is row 2, this is row 3. You can take row 3, along with row 3 we can multiply 2 times row 1 and write it as row 3. Write it as row 3 in the new matrix, the first matrix. So first row has no change, 4 1 3. Second row will be the same, 3 6 9. Third row will be R3, the previous row 3 plus 2 times row 1. So previous row 3 is 2, first element 2, second element 2 times 4. So 8 plus 2 10. So here second element 2 1 plus 2 times 1, 2 plus 1 3, and 0 plus finally 0 plus this 0 plus 2 times 3, 2 times 3, 2 times 3. So you will get 6. What we are doing is taking the old R3 and adding 2 times R1 term by term to the old R3. So you get a new matrix, call it D. So what is the purpose of this elementary row operation is it will retain the properties of A. See, now all the properties of A and D are equivalent. The rank of A is 3, then the rank of D will be 3. So this elementary row operations will retain the properties. Next we will see what is reduced matrix. Some notations have been given here, you can go through it. Next, reduced matrix. A matrix is said to be reduced matrix provided that all the following conditions are true. First one, all 0 rows at the bottom of the matrix. Second point, for each non-zero row, a leading entry is 1. All other entries in the column are 0, right? Third point, we will see all the three points together. The leading entry in each row is to the right of the leading entry to the above row. Okay, leading entry in the above row. So let's check all the 3 points with an example. Let me give you two different matrices. 1 0 0 0 1 0 0 0 1 0 0 0. This is a matrix of size 4 by 3. Let me take another matrix B. 0 1 0 0 0 0 1 0 0. Let me take another matrix C here. 0 1 0 1 0 0. This one can be B matrix can be 0 0 1. Okay, now let me discuss let me check matrix A first. All the zeros are on the bottom. If there is any 0 rows, if you can write, in other words, if there is any 0 row, it should be in the bottom. If there is any 0 row, it should be in the bottom. So here there is only 1 0 row. This is the 0 row. All the elements of the row are 0. Therefore, it's called 0 rows. So if there is any 0 row, it will be in the bottom. That's right. True for this matrix. And leading entry is the first non-zero element. These three are non-zero rows, isn't it? First three are non-zero rows. The first non-zero element in the row is its leading entry. So this leading element is 1. Okay, leading entry is 1. Second point is going on. And all other entries in the column. See, in this column of this 1. This is the column 1, isn't it? All the entries are zeros. Okay, that's good. Second row, this is the leading entry 1. And all the column elements are zeros. Third row, this is the leading element 1. And all the column elements are zeros. Third point, now we have checked first two conditions for matrix A. Now let's check the third one. The leading entry in each row to the right of the leading entry of the previous row. I mean, see, first row has the first element as a leading element, and second row has a leading entry which is right side of the first one. Not in this side, this is wrong. So it's in the right side of the first. So it will go rightwards. The leading entries will go rightwards, just like diagonal, or it can be here as well, but it should be right side. That's it. It should be right side of the previous row. That is the meaning. So matrix A fulfills all the three conditions. So this is a reduced matrix. Let's try B. What's wrong with B? What's the failure? Any zero row should be in the bottom, but here 0 row in the middle. That's the first failure. The first point itself is failure. All other points are good. You see, there is a leading element is 1. If it's not another number, isn't it? 1. And all the column elements are zeros. Here it is in the right side of the previous leading element, and all the column elements are zeros. Leading entry is 1. All other points are true, but 0 row is not in the bottom, it's in the middle. So this is a failure. And let's see what is wrong with the C. Is it a reduced matrix? There is no 0 row, so no worry about point A. First point. Second point, leading entries are 1. Okay, this is leading entry is 1. Other elements in the column are zeros. Leading entry is 1. Other elements are zeros. Second point is good. But the third point, leading element is not in the right side. The second row leading element is not in the right side. It is a failure. It is in the left side. This is a failure, isn't it? So not here. If it should have been here. So that's a failure. Let us now check whether the following matrix is reduced or not. I'm giving a first matrix 1 0 0 3. This is the matrix size 2 by 2. Can you check whether this is reduced matrix? If not, tell me the reason. Identify the reason of failure. You see, there is no 0 row, no worry about the first point. And second point, leading element in the first case is 1. All other column elements are zeros. Okay, good. But in the second case, leading entry is not 1, it's 3. So that's a failure. So we say no, not reduced. Okay, not reduced. The next column will give you 1 0 0 0 1 0. Is it what is the size? 2 by 3 matrix. Is it reduced? Is it reduced? No, 0 row. So first point is not to be considered. Second point, there is a leading element. All the column elements are zeros. There is a leading element on the right side, and it's 1, and the column elements are zeros. All the points have been fulfilled. So this is yes, a reduced matrix. I will give you one more problem. 0 1 1 0. What is the failure, or is it a reduced matrix? This is problem number 1 2 3. Yes, leading elements are leftwards going. It should have been rightwards. So this is a failure. So this is no, not a reduced matrix. The next matrix is 0 0 0 0 0 0 5 cube. Certainly it is reduced matrix. No more reduction possible. Now the next matrix I am giving you 1 0 0 triple 0, second row 0 1 0. Obviously, you know, 0 matrix, 0 row in the middle. It should have been in the bottom. So this is a failure, isn't it? And not a reduced matrix. And finally, I'll give you one more problem in this case. Zero 1 0 3 0 0 1 2 0 0 0 0. All those rows. Now tell me, is it reduced matrix or not? This is 0. Yes, first element, leading element is 1, all the column elements are zeros. First point is good. 0 row in the bottom, that is good. And second row, leading element is 1, other column elements are zeros. That's it. All the points have been fulfilled. We don't worry about this 3 and 2. All the points have been fulfilled. So this is, yes, a reduced matrix. So there are many other problems in the exercise set 6.4. You can try find whether the matrix is reduced or not. I am going to the next case, reduce a matrix. Okay, we are going to use some procedure to get the matrices reduced. So we have to reduce this matrix 0 minus 2 0 1 1 2 0 4 by using elementary row operations, isn't it? The first thing, see, reduced matrix, you know, there are 3 conditions to be fulfilled. Like, so what we are going to do to get a reduced matrix, we will generate leading element 1 in every row. The first non-zero entry should be 1 in every row. That's, and in that particular column of the particular column of this leading entry, all other entries should be zeros. This is what we are looking. So I have to convert the first element 0 into 1, and it's a column element to 0. So can I switch these two rows? So what I am going to do, this is row 1 and row 2. Exchange, I mean interchange the rows 1 and 2. So what you get here is 1 2 0 4. The second row becomes the first row, and the first row 0 negative 2 0 1. Now we have interchanged. The first elementary row operation has been applied here. See, the first row R1 has got a leading element 1, and it's a column. All other column elements are zeros. Okay, now we satisfied with point number 2. Fine. In the second row R2, the leading element is now negative 2. I want it to be 1. I want it to be 1. See, this is row 2. So divide the entire row 2 by 1 row 2. We are going to write the new row 2 as R2 divided by negative 2. No change occurs in R1. 1, 2, 0, 4. R1 remains same, but row 2, the new row 2 will be the old row 2 divided by negative 2. So 0 divided by negative 2, 0. Negative 2 divided by negative 2, 1. 0 divided by negative 0. 1 over negative 1 over 2. See, now the second row got a leading entry which is 1, but its column entry is not 0. So I have to convert this column entry into 0 by writing a suitable formula, which is the third elementary row operation. You can check back to the third elementary row operation. What I am going to do here is I want to change occurs in row 1, not in row 2, isn't it? But row 2 should be used here. So row 1 remains the same in the new matrix. So row 2 remains the same, 0, 1, 0, negative half. But change occurs in row 1. I want row 1. Start from row 1. Row 1 is 2. So row 1 element is 2 here. 2 minus 1 will not be 0. But 2 minus 2 will be 0. So multiply row 2 by 2. Multiply 2 times. Multiply 2 with the row 1. Now you check this one for every element. How do you write the formula? Our leading element is in row 2, so we are supposed to use row 2 here actually, isn't it? And we want row 1. So row 1 R1 is R1 minus 2R2. If you are looking for R3, you start from R3 and use the row which there is a leading element, right? And multiply some constant number and subtract or add them. See, this operation can be done term by term. Now, how to use it? Roughly, I write here at the bottom. You can check here. R1, what is your R1? The old R1. 1 minus 2, 0, 4. Minus 2 times R 2 times R2. Multiply this R2 by 2. Write down here 2, 0, 2. This is R1, 2, 0, 4 is the first row. There is no negative here. Second row is multiplied by 2, 0, 2, 0, minus 1. Now subtract 1 minus 0, 0, 2 minus 2, 0, 0 minus 0, 0. And 4 minus up minus 1, 5. So this is our new R1. 0, 0, 0, 5. So we have reduced, actually 1 minus 0 is 1. This should be 1. Leading element is 1 and its column elements are zeros. In the right side of the again second row got a new leading element, its column elements are zeros, and there is no 0 row. So this is a reduced matrix. Now let us see a different problem in the textbook 10. So the problem I write here is not displaying here. 2, 3, 1, negative 6, 4 and 8, 1, 7. So we need to get a reduced form, isn't it? The first entry should be 1 and all the entries in the column should be zeros. And to the right of this leading element, this element should be 1 and all the column elements should be 0. That is what we are aiming to, right? So the next matrix, we are going to exchange these two rows. What do you get? Exchange R1 and R2. Interchange these two rows. What do you get? Yes, 1, negative 6 in the first row, 2, 3 in the second row, 4, 8, 1, 7. There is no change in row number 3 and of course in row number 4. Okay, and after solving this problem I will go to solve system of equations. Okay, this one we have done first, but now we got leading element as 1 and we have to convert this element, the column elements of the leading entry into these three elements into 0, isn't it? That is the second point. Okay, let me do one thing. I need to convert no change occurs in row 1 hereafter, isn't it? For this one, so row 1 remains same, 1 and negative 6. Change occurs in row 2, and need this element to 0. So start from row 2. Use row 1 where the leading element is. So R2 minus 2 times R1. You can check 2 minus 2, it's 0. Next, so it will be 0 here. Actually, we are looking for 0. We will write this one. R2 is 2 and 3 minus 2 times R1. What is 2? R1. R1 is here. 2 minus 12. So when you subtract 2 minus 2, it will be 0. 2 plus 2 is 15. So here we get 0 and 15. In this way we want R3, next row, R3, row 3. So start from row 3 minus the same number, the 4 should be multiplied here. R3 minus 4 times R1. If this is negative, then we will add them. That's it. So in this case, you apply the same kind of operation. So you will get 0, 32, and I will write the formula for R4, row 4. Again, all these numbers are positive, so subtract 1 time R1. It is R3, R4 minus R1 will be 0. So 7 minus 1 6 is 13. So that is it. And next step, see, we have got leading entry 1 in the first row and all other column elements are zeros. Now we have to get a leading entry here, the right side of the first leading entry, which is 15 here. So divide the second row by 15. That is next operation. Next operation is row 2 we want, which is row 2 divided by 15. What do you get? No change in the first row, 1 negative 6. When you divide the second row by 15, is 0 15, sorry, 0 0 1 0 32 0 13. The remaining rows will remain unchanged, right? Next we got a leading entry in the second row, which is 1, which is right side of the previous one. Now the other elements in that column should be 0. So we are going to write again formulas. So remember this matrix, and then I will write the formulas now. The final matrix what we got was 1 1 negative 6 0 1 0 32 0 31. So our purpose now is to get the other elements in the leading element column to 0, isn't it? So what's going on here? What should be done next is to write a formula. We are no change happens in row, isn't it? Row 2. So we are looking for a formula for row 1. We are looking for a formula for row 3 and row 4. No change in row 2. So we will write here 1 0 0 0 will never change. This will be 1. Other elements should be 0. The second column. So the formula R1 starts from R1 and deals with R2, isn't it? So R1 negative 6 plus 6 times R2. R2 is the row in which leading element is there. So everywhere we should use R. So R3, we want R3 start from R3. R4 start from R4. We need to use R2 in which the leading element is there, isn't it? So the number should be multiplied is the corresponding number of this row. So 32 minus 32 R2 here minus 13. If this is positive, write in negative. So this negative, write in positive. That's it. Now you operate them term by term, will get zeros here. So now we got a reduced matrix. The 0 rows are on the bottom. All the leading entries are right to each other. Right, the following leading entry is right to the previous one, isn't it? And the leading entry column, all the elements are zeros. All the points have been fulfilled. So this is a reduced matrix. Okay. Now we will discuss system of linear linear equations. a general structure I can write now. So I'm not explaining general structure, I'm directly going to solve a system of uh, equations by reduction method. We are going to take, this is the general form of you can take. So I'm giving a problem here. 2x plus 3y is equal to -1, x plus y is equal to 5, x plus y is equal to 1. So there are three equations simultaneously given in variables two variables x and y. So this kind of collection of linear equations called a system of linear. You can write in n number of variables, x1, x2, xn variables, and m equations. There are m possible equations. With the right hand side we call it b1, b2, b3. If all the right hand side the constants are zeros, then we call it a homogeneous system. Otherwise it is not. If at least one constant is non-zero, we call it non-homogeneous. Right? How to solve such a kind of equation? Now we collect an augmented matrix, collecting all the elements in the matrix. See, this is the quotient of x. So first x column 2 1 1, next y column 3 1 1. See, the quotient of x is here 2 1 1, that's written here in the column of x. The quotient of y is 3 1 1, 3 1 1. And of course not only x is separated by a line, it's a matrix called augmented matrix. We collect the right hand side solutions, that is right hand side, resources we call in system of equation, we call it resources. So -1, 5 and 1, this all called B, isn't it? So when we reduce this matrix, you will find zeros everywhere except the leading diagonals. So you will get the quotient of x is 1 here, quotient of y is 0. So x will be some value available this side, y will be some value available this side if the last row is 0. Otherwise there will be problem. We will check cases. So now we gonna reduce this matrix by using the same method that we have done in the last problem. Okay, again I write the matrix. The matrix is, the given equation is 2x plus 3y is equal to -1, 2x plus y is equal to 5, and x plus y is equal to 1. So the matrix will be the quotient of x 2 2 1, and the quotient of y 3 1 1, and the b in the right side, b -1 5 1, isn't it? Now we have to reduce it. Can we exchange row 1 and 3 so that this 1 will go here and this 2 can be moved here? So in the next matrix we are interchanging row 1 and row 3. So what we get is 1 1 1. There is no change in the second row. 2 1 5. Third row will be 2 1 2 1 2 3 -1. Fine. The second thing we have to, so we got leading element 1 here. We have to convert the column elements into 0. The column elements is 0, and then that is it. We will go and then we will make this element into 1 if it's not 1, and then make these elements 0 again. We will do for the third row, right? Now we have to write some formulas. No change occurs in row 1. Write the row 1 as it is. 1 1 1 1. Change should occur in row 2 and 3. So write the formula for row 2 here. What is it? Row 2 we are looking for. Start from row 2, and we have to use row 1. The operation between them is subtraction because there is no negative here. Subtract 2 times r1. So what do you get? This element and this element. This element will be 0 and find these two elements. What is happening here? R2, second row is 2, 1, 5, R2 and 2 times R1 minus 2 times R1. So this is 2, 2, 2. Multiply with 1, 1, 1 by 2. Subtract, you get 0, 1 minus 2 minus 1, 5 minus 2, 3. So 0 minus 1, 3. And finally, for R3, the operation of the rule will be again R3 minus 2R1. So R3, 2 minus 2 is 0, 3 minus 2 is 1, minus 1 minus 2 minus 3. Now you see, last two rows are identical. So when you make the column elements into 0, see, we need here positive 1. So we get the leading element here on the right side of the previous element, isn't it? So we can multiply by negative 1 or exchange these two rows, whatever it is possible. So I am going ahead with the multiply. We want R2, the old R2 multiply by negative 1. So what you get here is 1, 1, 1, 0, 1, 3, 0, 1, 0, 1, negative 3, 0, 1, negative 3. In the next step, I have to convert these two elements to 0. So I have to write two formulas. For R1, I need to start from R1, I need to use R2. That's it, the coefficient is 1. So what is it? R1 minus R2 is 0. The first column has no changes, 1, 0, 0. Second row will remain same. So this we are writing first row now 1. R1 minus row 1 minus row 2. 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 3 is 4. Now write the formula for third row. R3 is R3 row 3 minus row 2 because we are in row 2. Row 3, the previous row 3 minus previous row 2. Subtract them, you get they are same. So you get 0 row. Yes, same. So the 0 row in the bottom, leading elements are 1. The second leading element is the right side of the previous one. So this is reduced form. We got the reduced form. So by using the reduced form, how to write the answer? That's our next step. So the reduced form is 1, 1, 0, 4, 0, 1, negative 3, 0, 0, 0 is the reduced form we got, isn't it? So this is the column for x, this is the column for y, this is right side. We have separated this one by a line. Now this x first multiply, this is just right back to the equation. So this is x, 1 time x plus 0 time y is equal to 4. Second one is 0 time x plus 1 time y is equal to negative 3. This will give third row 0, isn't it? Okay, if there is a non-zero element here, then it is inconsistent. It is not equal, isn't it? So we had right now, this is x is equal to 4, y is equal to negative 3. That is the solution of the system that will satisfy the given problem. That is it. That's the end of this problem. You guys can try the remaining problem, the PowerPoint. If you have any doubt, you can ask me later. Thank you very much.